Here we have AP calculus AB problem. Okay, let's go with the information. Find the exponents of any point of inflection on the graph of y equals to 1 over 20 times x to the fifth power, negative 1 over 6 times x to the fourth power, positive 4x, and negative 3. Okay, first let's understand what is the point of inflection. So point of inflection is a point at where the graph changes from concave up to concave down or concave down to concave up. So how do you have to get such a point? So for that, what we have to do is we have to find the first derivative and the second derivative of the given function. Okay, let me write the given function as this. It is 1 over 20, y equals 1 over 20 times x to the fifth power, negative 1 over 6 times x to the fourth power, positive 4x, negative 3. Okay, now let me find the first derivative of this one. That is, I'm going to find the derivative on both sides with respect to x, because y is a function of x. So when I find derivative of this y with respect to x, I'm getting dy over dx. So here it is a constant. I mean 1 over 20 is a constant multiplied by the variable. When I find derivative, if there is a constant multiplied by the variable, I have to keep the constant as it is, and I have to find the derivative of the variable alone. When I find the derivative of this x to the fifth power, it will become 5 times x to the fourth power. I use the power law of derivative. That is, I just got the exponent in front of the variable and subtracted 1 from the exponent. Negative, again 1 over 6 is a constant multiplied by the variable. So when I find derivative, I have to keep this constant as it is. When I find the derivative of this x to the fourth power using the power law of derivative, I'm getting 4 times x to the third power, positive. So here the constant 4 is multiplied by the variable. Since the constant 4 is multiplied by the variable, we can keep the constant 4 as it is. When I find derivative of this x with respect to x, it will just become 1, negative. So it's just a constant. Whenever I find derivative of a constant, it will become 0. So let's do some simplification over here. Dy over dx equals to, now we can simplify 5 goes into 5 1 times and 5 goes into 20 4 times. Then I'm getting 1 over 4 times x to the fourth power, negative. So here we can do some simplification. So 2 goes into 4 2 times and 2 goes into 6 3 times. Then I'm getting 1 times 2 is 2 over 3 times x to the third power. Positive 4 times 1 is 4. Okay, now I have completed the first derivative. Now I'm going to get the second derivative with respect to x. So when I find the second derivative with respect to x of this dy over dx, it will become d square y over dx square. So some students will find it difficult to understand this one. So d square y means we find the derivative of this y for the second time. So that's why I'm taking exponent 2 for d. So here in denominator, I'm taking exponent 2 for x. That is, both the times I'm doing derivative with respect to the same variable x. Okay, now on the right side, we have to do the same process. So here it's a constant multiplied by the variable. So the constant 1 over 4 to be kept as it is. We can find the derivative of this x to the fourth power using the power law of derivative. Then I'm getting 4 times x to the third power, negative 2 over 3 times. When I find derivative of this x to the third power, I'm getting 3 times x square. And positive, the derivative of this constant 4 is 0. Now let's do some simplification. So that is d square y over dx square equals to this 4 will cancel, and here 3 will cancel. 1 times x cube is x cube. Negative 2 times x square is 2x square. In our next step, we can factor the expression over here. Let me write the stuff over here. D square y over dx square equals to, okay, to factor the expression over here, we have to get the greatest common divisor for these two terms. So clearly the greatest common divisor is x square. So we can factor x square out. So to get the stuff inside the parenthesis, I have to divide the terms of this expression by the one I factor, that is x square. When I divide this x cube by x square, I'm just getting x. When I divide this negative 2x square by this x square, I'm getting negative 2. Okay, now I have factored this expression. So now what we have to do is we have to equate this second derivative to 0. That is d square y over dx square is equated to 0. Then I'm getting x square times x negative 2 equals to 0. So the product of these two terms equals to 0. Whenever the product of two terms equals to 0, either the first one equals to 0 or the second one equals to 0. Now to solve for x in this equation, we have to get rid of this exponent 2. For that, I'm taking square root on both sides. So then the square root and square will cancel. I'm getting x equals to square root of 0 is still 0. Now to solve for x in this equation, I have to add 2 to both sides. When I do so, this negative 2 positive will cancel out. I'm getting x equals to 2. Okay, now what we have to do is we have to draw these two values on the number line, real number line. Let me draw it. So on the real number line, on the left side extreme, we have negative infinity. On the right side extreme, we have positive infinity. So here we have to write these two values in order. So 0 should come first and 2 should come next. Okay, so by plotting these two numbers on the number line, we can split up the real number line into three intervals. That is negative infinity comma 0, 0 comma 2, and 2 comma positive infinity. Okay, now what we have to do is we have to check each of these three intervals with the second derivative over here in the result of second derivative. Okay, let me check the first interval, that is negative infinity to comma 0 with the second derivative. For that we have to take a random value in this one. So let me take a negative 1 as a random value in this interval. Now when I plug in negative 1 into the result of the second derivative, what will happen? I don't need the exact value, I just need what is the sign of the second derivative. So when I plug in x equals to negative 1, so negative 1 whole square will just become positive 1, this one. And when I plug in negative 1 over here, negative 1, negative 2 will become negative 3. So positive 1 times negative 3 will become negative. So that is the second derivative becomes negative in the first interval, negative infinity comma 0. Okay, now let me check the second interval 0 comma 2 with the result of this second derivative. So for that we have to take a random value. Again, I think we can take the random value 1 because we have 1 between 0 and 2. So when I plug in x equals to 1 over here, it's 1 square is just 1. And 1 negative 2 is negative 1. So negative 1 positive 1 times negative 1 will become negative 1. So in the second interval also the second derivative becomes negative. Okay, now let me check the third interval 2 comma positive infinity. So for that we have to take a random value. So let me take 3 as a random value in the third interval. Let me plug in x equals to 3. So when I plug in x equals to 3 over here, 3 square is 9. And when I plug in x equals to 3 over here, 3 negative 2 is 1. So 9 times 1, that is, this is positive value, this is positive value. When I multiply two positive values, the result is positive. So in the third interval, that is in 2 comma positive infinity, so the second derivative is positive. Okay, so in any interval, if the second derivative is negative, so I have to decide the graph of the given function is concave down. So in this interval between negative infinity and 0, the graph of the given function is concave down. So in the second interval also, the graph of the given function is concave down because the second derivative takes negative sign. And in the third interval, that is between 2 and positive infinity, the graph of the given function is concave up because the second derivative is positive over here. So when the graph of the given function passes through x equals to 0, it does not change its concavity. That is on the left side of x equals to 0, the graph of the given function is concave downward. And the right side of x equals to 0 also, the graph of the given function is concave down. So it does not change its concavity. So we don't have a point of inflection at x equals to 0. Now let me consider the second value of x, that is x equals to 2. On the left side of x equals to 2, the graph of the given function is concave down. On the right side of x equals to 2, the graph of the given function is concave up. So when the graph of the given function passes through x equals to 2, it changes from concave down to concave up. Since it changes from concave down to concave up, so we have a point of inflection at x equals to 2. So the exponent of the point of inflection is x equals to 2. So there is only one point of inflection for the graph of the given function. At that point of inflection, the exponent is 2.